So this section is kind of like a middle like aside for just a little review on absolute values and I would encourage people to watch it, which is maybe silly to say in the video because you're probably already watching it, because it really puts a lot of future stuff into perspective. That's going to help with the rest of this section. So we informally think about absolute values as making something positive, but we can also define absolute values with piecewise functions, right? The absolute value function, which is defined by those vertical bars, well, if the input's negative, then we just look at the opposite of the input. That makes it positive, right? A negative times a negative is a positive. So if the input is negative, this makes the output negative. And if the input's positive, well, absolute value function just gives you the same number. Absolute value of positive 2 is just positive 2. So that's how we can kind of combine it with some of the stuff that we've talked about. So for this section and for a lot of other applications, it's going to be useful to think of the absolute value as a measure of distance. So the absolute value of a minus b is the distance between a and b. It's the difference between them, a minus b, and distance is always positive. So that's why the absolute values are there. So describe all the values x that are within a distance of 4 from the number 5. We use a number line and absolute values. Let's start with a number line. So we're looking at the number 5, and we want to know what are all the values that are within 4 of that. Well, 4 above is going to be 9. 4 below is going to be 1, right? This is a distance of 4. And all the values that are within that distance, well, we could draw an open circle here, an open circle here, or use parentheses and connect them. So in interval notation, it would just be from 1 to 9. How do we do this with absolute values? Well, a distance of 4. What are the x's that are distance of 4? A minus b is the distance between those two things. So, we don't want a distance between x and 4, though. We want the distance between x and 5, right? Distance from the number 5. So the distance from the number 5 looks like this. This is the distance between the first thing and the second thing, the distance between x and 5. And we want to know all the x's that are within that distance of 4. So when is the distance not more than 4? I'm not actually sure English-wise. I think within would be closed circles. I think that includes it. Yeah. I'm not very good at English today. Well, any day. So that's how it looks like in a number line. And this is how it looks like with absolute values. So you can see where we're going with this. We're going to eventually solve absolute value inequalities. And we can think about those as distance questions. Example 6. So this is crazy to me, by the way. In 2023, really a blast from the past in a negative way. A 2010 poll reported that only 78% of Americans believed that if you're gay, you should be able to serve in our military. With a reported margin of error of 3%. That's like 95% confident. We're 95% confident that even though we took a survey and got this result, the actual number, which is not going to be the same as the survey result, is within 3% of this. This margin of error tells us how far off the actual value could be from the survey value, with 95% confidence. Express the possible set of values for the real number of Americans who believe this, not just the ones that were sampled, using absolute values. Well, we know the distance between our actual number and our reported number is going to be less than or equal to 3%. So our actual number was 0.78. The true number, we can call that a p or any other variable. This should be it. Or if you wanted, right, p is the proportion. If you wanted to, you could have p be the percent. You could say, well, p minus 78 should be less than or equal to 3. Same equation. Just, it's not an equation. Same inequation. What if instead of equations and inequalities, we were consistent? Equations and inequations, or inequalities and qualities? Think about that as you're falling asleep tonight. So either one of these is going to be fine. Pause the video. Try to do the same kind of thing. Students who score within 20 points of 80 will pass some test. Write an inequality describing the passing scores, which we'll call X, with absolute value notation. So the distance between X and 80 should be less than or equal to 20 points. Also, if you wanted to write the distance between 80 and X, it should be less than or equal to 20 points. That's the same, right? The distance between A and B is the same as the distance between B and A. Unless you're flying. If you're flying around the world, the way to go from one city to another, they probably aren't going to go the same way as same city back. That's why we have different flight times. There's also like headwinds and tailwinds. Anyway, but for our distance, they're going to be the same thing. So this is kind of an introduction to absolute values and how we can kind of think about them as distances. And that's going to make the next two videos a little simpler, I think.